Another application of the rules and properties of logarithms is when we attempt to solve logarithmic equations. First, I want to give you my perspective. You can have a straightforward definition of a logarithm approach, which is what I'm going to call, my own words, single log equals a number. And when you have a single logarithm equals a number, then you can rewrite the logarithm in exponential form. Now, the equation you have before you is not a single logarithm. There is an equal to a number on the other side, but if we can make it single log equals a number, then we have a shot at solving the equation. Before you move too far into the solution process, I always want you to make sure you note the domain of the equation. And in this case, the equation would require that each argument of each logarithm be positive. So you'll come back and check against that. Okay, but how do we make this single log equals a number? Well, you have log minus log, so you can write that as single log. In this case, it's natural log of a quotient equals the number 3. We know from our shorthand definition that natural log means log base e. So using the definition of a logarithm above, we can rewrite this statement, log base e of the quotient equals the number 3, as e to the third power equals the quotient. Now it's easy to get tripped up here. You don't want to focus on the e. E's the number 2.71828. X is the variable. So remember, e in this case is a number. Okay? So I can write e cubed times x minus 7 equals x by cross multiplying. I can say the number e cubed times x minus the number 7e cubed equals x from distributing. But my ultimate goal is to solve for x. I see x in each term is linear. That tells me I can isolate x. And when I do, I see that I can factor out the common x. And then I can solve the equation. Now, you don't want to assume that this is your answer. You want to check it against the problem's domain. So is this a positive number? Well, e is 2.71828, so e cubed is definitely bigger than 1, so you have a positive number for sure. And when I look at 7e cubed divided by e cubed minus 1, e cubed minus 1 is slightly less than e cubed, so when we divide that into 7e cubed, we have something slightly bigger than 7, so both of these check. Now don't guess. Please don't guess. Use your calculator. All right, another type of equation you could encounter is what I'm going to refer to as logarithm equals a logarithm. And in the logarithm equals a logarithm world, you're using the one-to-one property of functions to help you solve the equation. So I take a look at this equation and I see log of x plus 8 minus log of x equals 2 log of 10. Using the second rule of logs, I can write log minus log as log of the quotient. Using the third rule of logs, I can write log base 10, because the understood base here is 10, of 10 squared. And then I can say if and only if their two arguments are equal. And I can write this as x plus 8 equals 100x or 8 equals 99x, or 8 over 99 equals x. But I need to stop, because if I don't check the domain, as I was saying, if I don't check the domain of the equation, then I would be remiss. So the domain of our equation is that the argument x plus 8 has to be positive, and the individual argument x has to be positive. Okay, well, certainly 8 over 99 is positive, and certainly if I add 8 to it, it's positive, so it's check and check, and this guy is my solution. And lastly, just a little twist on things. It still is a log equals a number format. So what I see before me is log base a of something equals 3. I note the domain of the equation is I need to check against. I need x minus 2 to be positive. And I do have already a single logarithm equals a number, so the base a cubed must be the quantity x minus 2. And you're told to solve for, read it again, x. And in solving for x, we can write it in terms of the quantity a. Okay, so really, guys, I mean, they boil down to simple forms. All of them could be made into log equals a number with the convenient manipulation of rules, but you may want a shortcut sometimes and just have log equals a log. And you can handle the approach of most logarithmic equations this way.